This video is going to cover antenna analysis and matching using AWR Microwave Office. We're going to start by opening an antenna example. And just to cover that, basically, when you select Help Open Example or File Open Example, there are several hundred examples, but you're easily able to search for a specific type. So I type antenna, and these are all the antenna examples. They vary from patch antennas to phased arrays, various types. In this case, we're going to go with the log spiral antenna. It's pretty simple. I'll select that. And this is the project that is opened. The spiral antenna itself is here. And the first thing we're going to do is simply analyze it. This project is set up at a single frequency, 5 gigahertz. And so when we run it, we have the mesh that's visible. And you can see that getting pretty dense down in the small area where the two halves connect and where the port is. And then we have S11 for the antenna. And these are antenna pattern plots. So we have a left-hand and right-hand plot. We can also pull up a 3D plot or 3D layout, and that will give us the pattern for the antenna in 3D. So that is fairly useful, especially as we match and look at these patterns. But we're going to focus here just on matching. We can see that this antenna is nowhere near the center of the chart, which would be a 50 ohm match. So I'm going to delete this, and I'm also going to modify the trace, because we're going to have a second trace there, and we don't want to override the new one. So we're going to make this a bit smaller. Okay, this is the pure antenna match. Now, for us to match the antenna, what we would do is create a new schematic, and I'll just call this match. First thing we would do is put the antenna in as a substrate, subcircuit. So subcircuit, there's the antenna listed as a 1 port, and here it is. Now we'll put a port. This is our 50 ohm that we're going to match to. And if we were to add the measurement to this, we'll say match S11, and I'm going to make this a circle, and it's going to be larger than the blue square. So at this point, we run the circuit, and we can see that both of these points are in the exact same place. And that makes complete sense, because right now all we have is a 50 ohm port connected to the antenna. And that's effectively how S11 is measured on the antenna itself. And we can see identical results. So when we match an antenna, we will typically use inductor and capacitor components. and they will move on circles associated with the Smith chart. However, right now we have the impedance circles, and the inductor will move on these circles. For the capacitor, we would need to have the admittance circles. Now, this can be a bit complicated, but it is very useful for this type of match, as we'll see in just a second. I'm going to go to Options, Grid, and I'm going to add admittance grid along with impedance grid. And we can now see a perfect mirror of the impedance circles. So here are the smaller circles, and as we go to the right, the admittance circles are getting larger. And these are the circles that the capacitor moves on. Inductor on these circles, capacitor on these circles. Okay, so now that we can see how we're going to move, ideally we would have a capacitor, a shunt capacitor, that would bring us down in this direction, following the circle, until we intersect this circle, which moves directly up to the center of the chart, and that would be a series inductor. So here, I will start by adding capacitor. We will ground this, and I will set this to be tunable between 0 and 1 picofarad and 0.01 picofarad step size. See, this is now blue, indicating that it's tunable. And now if we pull up the graph again, we can see that it's jumped all the way over to here. And what we want to do is pull up the tuning slider. Now, the default value is 1, and that is literally the highest value that I permitted. And we can clearly see that we're well past this circle from here where we started. So we're simply going to reduce the capacitor value, and we'll get that's pretty well centered on the circle that we want. This is going to be the series inductor circle. So value 0.34 picofarads puts us right where we want to be. Put this on the side, pull up the schematic again. And now we want to delete this wire. Under Elements, Inductor, we will place an inductor. And this one, we are going to go tune the value. We're going to start at 2. We want to limit it from 2 to 4. Okay. So now we have the inductor tunable. Again, it's got a blue component, which means that it can be tuned. Pull this up, and we've moved a little bit up. We need to go further. So I start moving this, and As you can see, we're heading up directly to the center. And in order to make it as accurate as possible, I'm going to zoom in. Just a quick note, the roller wheel on your mouse operates with 100% Windows properties. So if I just scroll the wheel, we scroll up and down. If I hold the Shift key and scroll, we slide left and right. And if I hold the Control key, then we are going to zoom centered on the mouse. Now I want to center right in the center of the Smith chart. So we are zoomed just about all the way in. And I will now continue moving this up. Just makes it a little easier to see when we are perfectly centered. And I would say it's right about there. So if we close this, and we'll zoom this back out to its regular side, and we could now take off the admittance grid to make this a little simpler. But you can see that we effectively moved from here to this circle and up to the center to complete our match. And if I were to put a marker on this, you can see that we're very close to a pure 50 ohms, 50.14 ohms, and the non-resistance value, the admittance value, is very, very close to zero. So we have matched this antenna. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.